Welcome to this continuing discussion of the ISLM model, where in our previous discussions we focused on the IS relationship on its own and the LM relationship on its own. And our goal today is going to be to put the two together to finally get our ISLM model with all the pieces in place. We're first going to do that with algebra, then we'll turn to thinking about it with the geometry. And in order to do the algebra, we'll need to dig up from our previous discussions our IS and LM equations. So I've written them down here. We have our LM relationship from before was r equals 0.4y minus 10. It's a positive relationship. If we plotted this out, that LM curve would slope upward. And then our IS equation was r equals 13 minus 0.5y. It's a negative relationship. If we plotted it, it would slope down. And since we have two equations in two unknowns, the natural thing to do is to set up an equation and solve for one of the missing variables. In general, it's easier to do this by setting the two r's equal to each other and then solving for y. So we'll illustrate that method. So we've copied that down. We took IS, moved it here. We got 13 minus 0.5y. We took LM, moved it over here. We have 0.4y minus 10, and now we just got to solve. So let's get all the y's on one side and the numbers on the other. So we'll move the minus 10 to the left-hand side, and we get 23. We'll move the minus 0.5y to the right, and we get 0.9y. And now we have a bit of a mess, because if we solve out for y, we have that it's 23 over 0.9. That's not the kind of calculation you want to do in your head, so you bust out a calculator and you can round this off. It's approximately 25.55, or even you could just say 25.6. Alright, so now that we know y, let's take this number for y and plug it back into either our LM or our IS equation. We should get the same number for r either way, so really the best thing to do would be to make sure that you do get the number, regardless of which one you pick. But for simplicity, we'll just plug it into the LM curve. So we'll do 0.4 times 25.55 minus 10. And when I do that, I get 0.22. So I put that into my calculator, I got 0.22. Hopefully you can verify you get the same at home. So now we've solved for our equilibrium, interest rate, and output. We see how those are the two key endogenous variables, and our model helps us predict them. We did that in algebraic terms. Now what we'd like to do is transition and talk about this with geometry. So I've gone ahead and made a plot of r against y, and I've plotted both my LM and IS curves. Forgot to label my IS curve. My IS curve, remember, was 13 minus 0.5y, so it starts at this 13 for its intercept, and then it slopes down by 0.1 all the way to 26. My LM curve, on the other hand, starts out negative for really low values of y, and then eventually becomes positive starting at 25, and then just keeps sloping up with a slope of 0.4. And we can see based on the diagram, they must intersect at some point, right? This is our equilibrium point. Now, the diagram doesn't tell us quantitatively exactly where that is. It looks like it's between 25 and 26 for y, and it looks like the r is pretty small, but we couldn't really say how small, and this is where the algebra really complements the geometry. The algebra let us calculate earlier that this point here for y is 25.56 or 55 we said, and that this r here was 0.22, so quite small. And this is important, right? Because this allows us to analyze our ISLM model geometrically. The real application of the geometry is not so much to get specific numbers here, but it's to do comparative statics. So our next discussion, we're going to reproduce graphs like this, but sort of leave out the numbers, just look at the upward sloping LM and the downward sloping IS, and imagine what if something changed that would shift one of these curves. For instance, maybe government spending changes, or taxes are cut, or the Fed, for instance, increases the money supply. We'd like to be able to do comparative statics for each of those scenarios, and the geometry, it turns out, is much better than the algebra for getting qualitative answers to questions like that.